Hello, guys. So, our final chapter we look at international trade and trade policy, and I think it's a very important concept, always becoming one of the most important concepts in modern economics or contemporary economics. Is an undeniable fact that we live in an interconnected world where hardly most of the goods and services we consume on a daily basis are solely produced by the United States. In fact, majority of the goods we consume all consumed are produced by multiple countries. For example, the shirt I'm wearing right now was made in Bangladesh. My Hydro Flask was made in China. My PlayStation 4 was made in Japan. So we do have a plethora of goods that we use that actually sort of produced outside the United States and not necessarily just outside the United States, but by multiple countries. And that is what international trade is all about, the exchange of goods and services. Okay, so that is what this chapter basically is going to be looking at, exploring the exchange of goods and services between countries and some policies in limiting and to some extent sort of reducing free trade. Okay, in this chapter we're not necessarily looking at policies that will actually promote free trade, even though we as economists know free trade is beneficial for most countries. But we'll look at the other arguments where people actually or scholars actually argue that free trade could be detrimental to the country and to infant industries or to local industries. So we look at trade policy in the sense of actually trying to limit free trade. Okay, so that's what we're trying to look at in chapter 15. Okay. So mainly this chapter will explore trade theories used in economics and policies put in place to, like I said earlier, reduce trade. We'll explore first of all. So I'm going through the learning objectives. We explore the concept of comparative advantage, and it's being the main basis for trade. So the whole idea of comparative advantage basically sort of helps us in answering the question of why countries actually trade in the first place. We'll also contrast production and consumption in a closed versus an open economy. So we explore the definition of a closed economy, we explore the definition of an open economy, and we'll look at production and consumption in those kinds of economies. Okay. With economics, we're always interested in the optimal amount of goods that can be produced. And likewise with trade theory, we're also interested in the optimal amount of goods that have to be traded, right? So we're looking at the optimal amount of goods that have to be imported or exported, and generally who wins or loses from trade. So in terms of trade, there's always going to be winners of trade and there's always going to be losers of trade in terms of like different sectors in the economy. So not between countries, but different sectors in the economy and different agents in the economy. So when we say agents, we're talking about consumers and producers. Okay, so do producers lose from free trade? Do consumers lose from free trade? Do producers win through trade, or do consumers win through trade? Okay, so that is the third learning objective that we'll take a look at. And like I said earlier, according to some scholars and according to some economists, and this, to be honest, is really few, trade is quite controversial. And these scholars actually prefer, or these economists actually, or there's this school of thought, they actually prefer a country to be self-dependent. So we explore policies that actually put in place to actually limit trade and protect the economy or protect local industries in the economy. Okay. So these are the learning objectives, and again, for me to actually understand sort of like a chapter, I always go through the learning objectives, making sure I actually cover every single part of it. So you need to understand what comparative advantage is really crucial. You need to know the difference between a closed economy and an open economy in terms of trade. Okay, we need to also know the winners and losers of trade, and then we need to look at sort of trade policies. Okay, so why is trade often controversial, and policies in trying to reduce trade. Okay, so those are the main key things I will actually focus on. Right, so in looking at trade theory, the first thing we need to consider is, why do we trade? Okay, so why do we actually trade, or why do countries trade amongst each other? And we already know the answer to this. It doesn't really take sort of much knowledge to actually answer this question. Why do we trade? Well, the answer to this question is pretty easy. And we trade because we cannot produce other goods and services ourselves. Okay, so the United States does not produce much goods and services, or cannot produce all the goods and services they need to produce, because of course they have limited resources, right? So remember we said with the definition of economics is how we manage choices given limited resources. Okay, so how do we manage production and consumption given limited resources? And that's the whole point of microeconomics, right? So we do have the whole concern of limited resources, and because of that we cannot be self-sufficient. We do need other countries to sort of depend on in terms of, you know, creating other goods and services for us that we can enjoy. Right, so we trade because we cannot produce all the goods and services ourselves, because at the end of the day we have limited resources, right? But however, that leads us to another question. Okay, so the other question that we sort of, or that sort of arises, is how do we know what goods we are best at producing and what goods we are really bad at producing, right? So in other words, how do we know what goods we should produce, okay, and what goods we should not produce, and we should let some other country basically produce for us, right? So that is the whole sort of, you know, existential question behind the fact that why do we trade. So actually understanding why do we trade is pretty easy, but we should know what we should actually produce in order to trade and exchange for other goods and services. And that's what we actually delve into. Okay, right. So economists have always been thinking about this, and 18th century economists thought of this same question back then: what really determines trade, right? So a man of the name David Ricardo came up with a theory that is still used today, and his theory is called comparative advantage. Okay, right? And then actually sort of coming up with this theory, he used the good old concept of opportunity cost. And remember, we already talked about opportunity cost. What did we say opportunity cost was? We said opportunity cost is the best alternative for a gun. Okay, so opportunity cost is basically what you would have done, right, if you actually did something else. Okay, so that is the whole point of opportunity cost, and we use the whole concept of opportunity cost to actually look at comparative advantage. Okay, so comparative advantage is the first theory in trade, right? And this was developed in the 18th century, right? And I'm just going to read out the definition of comparative advantage, and we'll build on comparative advantage to actually understand why people actually trade and why countries actually trade. Okay, so comparative advantage, using the concept of opportunity cost, says that a person or a country has a comparative advantage over another person or another country if the person or country's opportunity cost, okay, so the key word is opportunity cost. Every time we talk about comparative advantage, at this point, I want you to think of opportunity cost, okay? So a person or a country has a comparative advantage of another if the person or country's opportunity cost of producing a good is lower than the other person's or country's opportunity cost of producing the same good. Okay, so essentially, if you use less resources in production of a certain good or a service, then you actually have a comparative advantage in that good or a service, right? So that is the whole point of comparative advantage. And again, it goes back to the whole concept of opportunity cost, right? So what is the best alternative? What do you need to give up in order to gain something else? Okay, what do you have to give up to gain something else? And that is the whole point of opportunity cost. Okay, so the lower opportunity cost is in actually trying to produce a good, the more comparative advantage you have. Okay, so this theory, given in the 18th century, right, by David Ricardo, basically tries to explain why countries trade. Okay, so countries should produce the good in which they have a comparative advantage in. Okay, countries should produce a good in which they basically have a comparative advantage in, and not produce the good in which they don't have a comparative advantage in. So another country will have a comparative advantage in producing one good, the other country will have the comparative advantage of producing another good, and then basically the exchange. So that is what trade is all about. Okay, so then it goes down to the principle of comparative advantage. Okay, so everyone does best when each person or each country concentrates on the activities for which his or her opportunity cost tends to be the lowest. Okay, so according to David Ricardo, in answering what countries should trade, he argues countries should trade in whatever good or service they have a comparative advantage in. Comparative advantage in the long run, according to him, benefits everybody. It benefits the person or country who actually specializes in whatever good activity they produce. And it benefits the person or country who is actually sort of receiving this good in exchange based on their comparative advantage. Okay, so that is the whole idea of comparative advantage. And that is the whole idea of trade as well. Produce whatever good in which you're actually good at doing. Okay, so for example, the United States is good at making computer chips from Intel and AMD, right? So the United States should actually concentrate on the production of computer chips, okay? Maybe France is actually good at producing wine, for example. So France should actually concentrate on the production of wine and hence exports wine, whilst the United States actually exports, computer chips. Okay, so that's the whole idea of trade. Okay, and why we trade is because we don't have the resources. Okay, what actually do we trade in? It has to do with comparative advantage. Okay, so now let's take a look at how comparative advantage works. Okay, so we're going to look at a fictional country known as Microland. Okay, and just to make things really simple for us, Microland will assume it's as an island. Okay, so we have a fictional country which is called Microland, and Microland is an island. Okay, so we can understand the comparative advantage concept if we actually look at a hypothetical economy. Okay, and to understand it further, we need to examine the concept of production possibilities curve. So that's something new I'll be introducing. Okay, so based on this example, I'll be introducing something we call the production possibilities curve. So now we have this fictional country called Microland, and Microland is basically an island. We also, for simplicity, assume that Microland produces only two goods. Of course, in the real world, things are not as pragmatic as this. Things are more complicated. But remember, with economics, we try to build simple models to explain, the abstractness in our real world, or the abstractness in the real world. Okay, so we just assume that Microland produces only two goods, or basically has only two goods. It has coffee and nuts. Okay, so you could think of this as coconuts or whatever. Okay. So Microland is an island and it has only two goods. It's able to generate only two goods. We have coffee and nuts. And let's just assume that there's only one person actually living on Microland. Okay, so Microland has one worker and we'll call this worker Claire. Okay, so we have Claire. She's basically stranded on this island. Okay, and this island produces coffee and nuts. Obviously, Claire needs to eat. Okay, she can't really go hungry on the island or else she will die. So let's assume Claire works 6 hours a day, right, to collect coffee and nuts. Okay, and with Claire, we can actually sort of measure her productivity. So with Claire, she can either collect 2 pounds of nuts in an hour or 4 pounds of coffee in an hour. Okay, so that is her productivity level for Claire. She can collect 2 pounds of nuts in an hour or 4 pounds of coffee in an hour. Okay, so Claire's productivity depends on what we call the production possibilities curve. And the production possibilities curve basically is a curve that shows you all the possible combinations of goods that Claire can sort of produce or collect on this island. Okay, the production possibilities curve is important because it also illustrates why countries tend to trade, and we'll actually go into that later. But I'm trying to build up the preamble and I'm trying to build up a synopsis. I'm starting from, a really easy perspective. Right, so based on her productivity levels, so we know that she produces 2 pounds of nuts in an hour, or she's able to collect or produce 4 pounds of coffee an hour. Based on her productivity levels, we can construct her production possibilities curve. Okay, and again, the definition for the production possibilities curve is that it shows the combination of two goods that can be produced with given fixed resources. So going back to our scenario, her resources are 6 hours a day. Okay, so she's able to work for only 6 hours a day. So basically that is her resource. All right, so combination of two goods, which is basically coffee and nuts, that can be produced given her fixed resources of 6 hours a day. Okay, with the production possibilities curve, there are a few assumptions that we need to hold to actually make our life easy for us, okay? First of all, the first assumption we hold is that only 2 goods are produced. So in this case of microland, which is the hypothetical example, and our country, we have the production of only coffee and nuts, right? And we also assume that resources are fixed, okay? So she's able to work 6 hours a day. She basically does not work less than 6 hours, and she does not work more than 6 hours, okay? So she's only able to work 6 hours a day, right? And she's able to collect 2 pounds of nuts in an hour, or she's able to collect 4 pounds of coffee in an hour. So given these assumptions and given her productivity level, we can sort of construct her production possibilities curve, okay? So we can actually have a table for this, okay? So with this table, we need to go through it slowly for you to understand it. So let's look at scenario A, okay? With scenario A, if Claire decides to use all the 6 hours to just pick up coffee, remember she can pick up 4 pounds of coffee in an hour, right? So she's using 6 hours a day to pick up only coffee, or to produce only coffee, is going to give us 4 times 6, which equals 24. Okay, so if she uses the whole day, right, if she uses a whole resources or fixed resources, which is basically 6 hours a day to produce just coffee, she'll produce 24 pounds of coffee, and she'll produce no nuts. Okay, now let's look at scenario B. If Claire decides to use 5 hours to actually pick coffee, right? So remember, she can pick coffee. She can pick 4 pounds of coffee in an hour. So she decides to use 5 hours. So it's going to be 4 pounds of coffee times 5. So that's going to be 20. Okay, and then she has an extra hour because remember, she has 6 hours a day to actually work. So she has an extra hour to actually pick up nuts, right? So she'll produce 20 pounds of coffee. And remember, she can produce 2 pounds of nuts in an hour. So then she'll produce 2 pounds of nuts. Okay, let's look at scenario C. With scenario C, let's say Claire decides to use now 4 hours to produce coffee or to collect coffee. So she has 4 hours. So that's going to be 4 times 4 because it's 4 pounds of coffee in an hour. So that's going to be 16. And remember, she has 2 hours left because again, she has 6 hours that she devotes to in production. So she has 2 hours left. Okay, so it's going to be 2 times 2. And then we have 4. So we have 4 pounds of nuts. Okay, so a combination is 16 pounds of coffee and 4 pounds of nuts. Okay, we can do so for scenario D as well. So with scenario D, she basically uses 3 hours. So it's going to be 4 times 3 to pick coffee. So we have 12. And she uses the other 3 hours to pick nuts, and then we have 6 nuts. Okay, so you can basically do that for multiple scenarios, right? And then we have scenario G, where she decides maybe she's allergic to coffee. She doesn't really like coffee, so she wants to use the whole day to basically pick up nuts. Okay, so she works 6 hours a day, and she can basically pick up 2 pounds of nuts in an hour. So that's going to be 6 times 2. And that's going to be 12. Okay, so she uses all her resources to basically focus on production of nuts, because let's just assume Claire is allergic to coffee. Okay, so in scenario G, she has 12 pounds of nuts and no coffee. Okay, so this is basically her production possibilities table or curve, right? And again, it shows you the combination. So A, B, C, D, E, F, G shows you the combination of 2 goods that can be produced given her fixed resources of 6 hours a day. Okay, and based on this, we can actually draw a graph. Okay, so remember, we economists always like drawing curves and graphs. Okay, so again, we're going to draw a graph to actually illustrate our points. Okay, so now we have Claire's production possibilities. So we assume 2 goods, coffee and nuts, and we assume that her resources are basically fixed. Right, so she works 6 hours a day. Right, now if Claire uses all her 6 hours to produce coffee, she'll produce 24 pounds in a day. So we have coffee on our y-axis, and we have nuts on our x-axis. Okay, if she decides to use all her 6 hours to produce coffee, she'll produce 24 pounds in a day. So that's 6 times 24, so it would be our point A. So we have 0 nuts and 24 pounds of coffee. If Claire uses all her 6 hours to produce nuts, she'll produce 12 pounds in a day. So that's 6 times 2. So she'll produce 0 coffee and then she'll produce 12 nuts. Okay. If for some reason she decides to use 2 hours for coffee and 4 hours of nuts, she can produce a point C. Right. So that's going to be 2 times 4. Because remember, she can pick 4 pounds of coffee in an hour. So that's 2 times 4. So that's 8 pounds. Okay. And she uses 4 hours to pick up nuts. So it's 4 times 2. And that's also 8. Okay. So maybe that's the best thing for her to do. She actually has equal amounts of coffee and equal amounts of nuts as well. Okay. Or she can decide to use 4 hours for picking up coffee. And she'll actually be at point B. And 2 hours for nuts. Okay, so she produced 16 pounds of coffee and 4 pounds of nuts. Okay, and this is given by the fact that an hour of labor, right, she can either produce or collect 4 pounds of coffee, or she can actually collect 2 pounds of nuts. Okay, and we can basically construct her production possibilities curve by connecting all these dots. Okay, again guys, if you have any questions or you don't understand anything, feel free to pause the video, just go back. Okay, you have all the time in the world, and that's the advantage of having a video. You have all the time in the world to actually understand something. You can always go back to it and just make sure you understand it before you actually have to move on. If you still don't understand anything, even after you've paused the video and looked at it several times, you can always shoot me an email and I'm more than happy to answer your questions. Okay, so that is how we actually construct the production possibilities curve. A few things we need to know about a production possibilities curve, and before I actually delve into this, we can actually extend the production possibilities curve to a country. Okay, so we can actually look at a country production possibilities curve, and we can say a country is producing 2 goods, let's say coffee and nuts. Okay, so our country in this case is Microland, and since Claire is the only worker in Microland, technically this is the production possibilities curve for Microland. So, okay, so we can say this is the production possibilities curve for Microland. Okay, and every country has a production possibilities curve. Of course, we can extend this to multiple goods and services, but just to make things simple, okay, we just extend it to just 2 goods. Okay, so now going to Claire's production possibilities curve, we can actually use that to actually see a few things about a production possibilities curve, or a few properties about the production possibilities curve. Okay, so we have the unattainable point. Okay, and the unattainable combination or the unattainable point is any point that is outside the production possibilities curve. Okay, so it's any point that is beyond the production possibilities curve line. Unattainable combination means she can't actually produce those goods given the resources. Okay, so in this example, she can't produce 16 pounds of coffee and also produce 8 pounds of nuts. Okay, so remember, for her to produce 16 pounds of coffee, she needs 4 hours. Because she collects 4 pounds of coffee in an hour. So she needs 4 hours to actually produce 16 pounds of coffee. So it's going to be 4 times 4. So that gives us 16. Okay. And to produce 8 pounds of nuts, she needs actually 4 hours. Because remember, you can collect 2 pounds of nuts in an hour. So she needs 4 hours to actually produce 8 pounds of nuts. But she doesn't have 4 hours. She doesn't have that extra 4 hours because she usually devotes 4 hours to coffee. Right, she's only going to have 2 hours left. Remember, she has fixed resources in the sense that she only has 6 hours to work in the day, right? She's living on an island. There are dangerous animals on the island, okay? Daylight is only for 6 hours, so she has only 6 hours to basically collecting our food, okay? Hypothetically speaking, okay? So this point right here is unattainable. Okay, she can't actually get to this point because she doesn't actually have the resources to actually get to that point. Okay, or get to that combination. And then we have the attainable points. Okay, any point. So we have point A, B, C. Any point on the production possibilities curve is known as an attainable point. It means that given her fixed resources, Claire can actually produce at those points. Okay, so any point, right, on this production possibilities curve tends to be attainable. Okay, and then we have what we call the inefficient point or the inefficient combination, right? And one more thing, I just forgot, I probably should have mentioned it, but any point beneath the production possibilities curve is also attainable. Okay, but then we have the inefficient combination, and we call it the inefficient combination because she's not using all her resources to actually sort of maximize her benefits. Okay, so she's not maximizing her resources. Okay, so for example, at this point, she's producing 4 nuts or 4 pounds of nuts. And she's producing 8 pounds of coffee. Right, which is totally doable, right? So remember, to produce 8 pounds of coffee, how many hours does she need? Well, she's actually able to collect 4 pounds of coffee in an hour. So to produce 8 pounds of coffee, she basically needs 2 hours. So that is 4 times 2, which will give us 8. And to produce 4 pounds of nuts, how many hours does she need? Well, she's able to collect 2 pounds of nuts in an hour. So to produce 4 pounds of nuts, she needs 2 hours. Okay, so that's going to be 2 times 2 to give us this 4. It means that in total, she's actually spent 4 hours, but Claire can actually do better. Okay, she actually has 6 hours in production, and she's using only 4 hours, right? So she can actually do better. So we say this point is not efficient. Yes, it's attainable, but then it's not efficient, okay? Because she can always do better. And as economists, we always want individuals or producers to actually do better. Right? So any point on the production possibilities curve is attainable and at the same time is an efficient point. Okay, so point A, B, C, and D are all efficient points. Why? Because Claire is actually maximizing her resources to actually produce some amount of good. Okay, so she's maximizing her resources to actually produce some amount of good. Okay, so that is the whole idea of the production possibilities curve. Okay, and not to sort of or not to digress or just move off in a tangent, we studying the production possibilities curve because we need to understand it in order to understand the whole concept of opportunity cost, and from there, understanding opportunity cost in terms of production, you can actually understand comparative advantage and can actually understand why countries tend to trade. Okay, so now let's look at the opportunity cost. Okay, so we have Claire's production possibilities curve. So now we can actually calculate Claire's opportunity cost. Okay, so the first thing we're going to do is calculate Claire's opportunity cost of nuts. Okay, so when we say opportunity cost of nuts, right, in other words, how many pounds of coffee does Claire give up in order to produce 1 pound of nuts? Remember, she has limited resources. She can actually produce either coffee or nuts. She can't produce both of them at the same time. In a way, she can't multitask. Okay, that is the assumption we actually held earlier. She can either produce coffee, right, or she can actually use her time to produce nuts. She can't produce both of them at the same time. So when we say the opportunity cost of nuts, it basically means how many pounds of coffee should Claire give up in order to produce 1 pound of nuts. And to actually do that, we use a really simple formula, which you guys can easily remember, okay, is the loss in coffee divided by the gains in nuts, okay? So if you're looking at the opportunity cost of, let's say, X, suppose you have 2 goods, X and Y, and you're trying to find the opportunity cost of X. This is going to equal the loss in Y, because you only have two goods, so loss of Y divided by the gain in X. Okay, so always think of the opportunity cost of nuts, right? The trick I always use remembering this formula is always the X or the nuts, basically the good we're looking for is opportunity cost, always goes in the denominator. Okay, always ends up going in the denominator. Okay, so in calculating the opportunity cost of nuts, again, in other words, we're trying to find how many pounds of coffee does Claire need to give up in order to produce 1 pound of nuts. We know that in an hour she can produce 4 pounds of coffee. So that is the loss in coffee, right? That is what she's given up in order to use that 1 hour to produce nuts. Okay, and we know that in an hour she can produce 2 pounds of nuts, so she gains 2 pounds of nuts. Okay, so the opportunity cost of producing nuts, or 1 pound of nuts, is basically 2 pounds of coffee. Okay, so that is how we calculate the opportunity cost in terms of her productivity. Okay, she needs to give up 2 pounds of coffee in order to produce 1 pound of nut. Okay, that is the whole point of opportunity cost. Likewise, we can find the opportunity cost of coffee. Again, the opportunity cost of coffee is how many nuts does she need to give up in order to produce coffee. Okay, remember again, we assume that she can't multitask. She can't produce nuts at the same time producing coffee. It's either she produces nuts or she produces coffee. Okay, so the opportunity cost of coffee is how many pounds of nuts that she needs to give up in order to produce coffee. Again, we use our formula, right? So we set opportunity cost of coffee. So we know coffee should go in our denominator and nuts should go in our numerator. Okay, so then we have loss in nuts, divided by the gain in coffee, right? So again, we know that in an hour she produces 2 pounds of nuts, so that's what she has to give up in order to gain 4 pounds of coffee. So it's going to be 2 pounds divided by 4, and we have half. Okay, so the opportunity cost of 1 coffee is half a nut, which actually makes sense. Okay, for her to produce 1 pound of coffee, she needs to give up the production of half a pound of nuts. Okay, so from here we can actually conclude that Claire has a lower opportunity cost in producing coffee than in producing nuts. In other words, it's more expensive for Claire to produce nuts than to actually produce coffee. Okay, because the opportunity cost of producing nuts is actually higher than the opportunity cost of coffee. So if we revisit David Ricardo in the 18th century or 19th century, right, he will suggest that Claire should specialize in the production of coffee, because for Claire it's less costly to produce coffee. Okay, so if Claire was a country or even for a person, she should specialize in the production of coffee. Why? Again, because the opportunity cost of coffee is less than the opportunity cost of producing nuts. So now let's complicate things a little bit. Suppose that Nathan got shipwrecked and finds himself on the island as well. So at first it was just Claire on the island, right? So we're still looking at the country of Microland. So we still have the country of Microland, and unfortunately, Nathan gets shipwrecked and he lands on Microland. Okay, and we still have the same assumptions, right? In Microland, daylight is really short, so you can only work 6 hours a day. Okay, you don't want to work at night because you probably get eaten by animals. Just saying. Okay, right. And we actually have Nathan's sort of productivity levels. Okay, so he also has 1 hour of labor, right? In 1 hour, using his labor, he can actually produce 4 pounds of nuts, which is different from Claire. Or he can produce 2 pounds of coffee. Right? So we can actually construct Nathan's production possibilities curve as well. So for Nathan, if he decides to produce only coffee and no nuts, right? Remember, he can collect 2 pounds of coffee in an hour, so it's going to be 2 times 6. So that is 12. So he's going to be at point A. If he decides to produce only nuts and no coffee, right, he's going to use his whole 6 hours to produce just nuts. So it's going to be 4 pounds. Remember, you can collect 4 pounds of nuts in a day, okay? So it's going to be 4 pounds times 6. 4 pounds of nuts in an hour, so it's going to be 4 times 6, and that is going to be 24. So it's going to be at point D, and basically you can connect this, and that will give us production possibility. Okay, so this is the production possibility for Nathan. Right. Again, we can actually find the opportunity cost, right, for Nathan. And we can actually, in terms of nuts and coffee, and we can actually determine what Nathan should specialize in. I will give you 30 seconds to just try and figure out the opportunity cost for nuts for Nathan, and the opportunity cost of coffee for Nathan. And then we'll just go for it. Okay, so first of all, let's look at the opportunity cost of coffee, right? So again, remember the opportunity cost of coffee is how many nuts Nathan should basically give up in production of 1 pound of coffee. Again, we're going to use our formula is loss in nuts, okay, divided by loss in coffee, okay? So in that sense, we basically have Nathan's opportunity cost of 1 coffee is 2 nuts, okay? So we have 4 divided by 2, okay? So to produce 1 pound of coffee, he basically needs to give up 2 pounds of nuts, okay? And likewise, his opportunity cost of 1 nut is basically half a pound of coffee, right? So it's going to be 2 divided by 4, okay? And that is the opportunity cost of nuts, okay? So according to David Ricardo, or according to the theory of comparative advantage, what should Nathan specialize in? Yes, you're right. Nathan should specialize in the production of nuts, okay? Because his opportunity cost of producing nuts is basically less compared to his opportunity cost in producing coffee, okay? Suppose now Nathan somehow meets Claire on the island. It's a small island, so somehow they actually meet each other, okay? We can actually construct our PPCs. And the PPC actually shows who has a comparative advantage in doing what, okay? So clearly we can see that Claire, no pun intended, right? Actually has a comparative advantage in producing coffee, like we said earlier, because her curve, or her production possibilities curve, basically sort of slopes or steeps towards the coffee side, which is basically our y-axis. And Nathan also has a comparative advantage in producing nuts, like we said earlier, because his production possibilities curve actually slopes towards the x-axis, which is basically nuts, okay? So Claire's curve is steeper and is better for coffee. So Claire should specialize in production of coffee. And Nathan's curve is flatter and steeps towards nuts. So Nathan should basically specialize in the production of nuts. Right? And again, comparative advantage is always a comparison. To get 1 pound of coffee, Claire gives up half a pound of nuts, and Nathan gives up 2 nuts. So Claire should basically produce coffee, right? And to get 1 pound of nut, Claire gives out 2 pounds of coffee, and Nathan gives out half a pound of coffee. So Nathan should basically produce nuts, okay? Now, how do we actually sort of bring this whole concept towards trade? Okay, so specialization is really important towards trade, because remember I said a country basically should specialize in whatever good it produces and then trade that good for whatever good it cannot specialize in. Okay, so without trade, each person can consume along their production possibilities curve. Remember, without trade, they can't consume beyond their production possibilities curve. We actually have the unattainable point over there. Okay, so what you produce determines what you consume. Okay, so in terms of where you actually have a closed economy, where you actually have no trade, okay, what you actually produce is only what you actually tend to consume. So production equals consumption when there's no trade. Okay, but with trade, people can generally be better off, meaning that you can actually consume more than you can actually produce, or what you actually produce. And we can illustrate this by just looking at Claire and Nathan. Okay, so with trade, always specialization comes with trade, and with trade comes with better consumption levels. Okay, all right, so you produce according to your comparative advantage, and you trade to get what you want. Okay, so now we combine Nathan and Claire. Okay, they meet each other. Okay, and let's assume that their preferred diet is basically having equal amounts of nuts and coffee. Okay, so their preferred diet is equal amounts of nuts and coffee. So in that sense, they produce 8 pounds of coffee and 8 pounds of nuts, and that is always going to happen at a point where the production possibilities curve basically intersects, which is right over here. Okay, so each produces 8 pounds of coffee and 8 pounds of nuts. Okay, but we know that Claire has a comparative advantage in producing coffee and Nathan has a comparative advantage in producing nuts. So we're actually going to show you that, or show that basically specializing in whatever you're good at producing makes you better off. Okay, so we should assume that Claire should produce only coffee and Nathan should basically produce only nuts. Okay, so in that sense, Claire will basically produce 24 pounds of coffee and Nathan will produce 24 pounds of nuts. Okay, right? But before specialization, they both produce 8 pounds of coffee and 8 pounds of nuts. Okay, so in that sense, if Claire produces 24 pounds of coffee and Nathan produces 12 pounds of nuts, then in that sense, right, she can actually trade 12 pounds of coffee. Okay, for 12 pounds of nuts. Okay, if she decides to actually meet Nathan. Likewise, Nathan will trade 12 pounds of nuts for 12 pounds of coffee. Okay, so if they actually decide to trade, so Claire produces 24 pounds of coffee. She doesn't want to consume only coffee. She wants to consume them in equal amounts, coffee and nuts. Okay, so she'll split her amount of coffee and trade for 12 pounds of nuts from Nathan, and Nathan will do likewise. He produces 24 pounds of nuts. Okay, he wants to consume in equal amounts, so he'll split his 24 pounds of nuts and actually exchange it for 12 pounds of coffee. So then in that sense, if they both consume 12 pounds of coffee and 12 pounds of nuts, they'll actually land over here, which is basically this point. Okay, and as you notice, this point, let me just call it A, is outside their production possibilities curve, but they can actually consume at point A. Why? Because they actually decide to trade. Okay, so trade allows you to consume outside your production possibilities curve. Okay, and that is the whole point of comparative advantage. Okay, And we can basically apply comparative advantage to countries as well. Right? So like I said earlier, France has a comparative advantage in producing wine because they have the right geography and climate and experience to do so. Okay? So they should basically specialize in the production of wine. Okay? So specialize in whatever good you have a low opportunity cost in. Okay? So the United States, for example, has a comparative advantage in the production of spacecrafts. Okay? So it makes sense for the United States to actually produce spacecrafts. Okay? And specialization tends to make everyone better off. Okay? Specialization tends to make everyone better off. Again, if you don't understand anything, just go back to the material, take a look at it, and try and understand it. If you still don't understand anything, please send me an email. Okay? The next time we'll look at production and consumption possibilities and the benefits of trade at the country level. So first we looked at it in terms of individuals, which still can be applied to the country level if you think about it. But we'll look at an example in terms of production possibilities and consumption possibilities and its benefits of trade in terms of the country level. Okay? Thank you, and I hope you guys stay safe. See ya.